Welcome. This is Professor Lori. Welcome to HDFS 380 Research Methods. I know it says FAMR. Let's just ignore that right now. If we knew what it was we were doing, it would not be called research, would it? I like to use that very confident quote from Albert Einstein to let you know that research methods can be a little messy. We have to do a lot of trying and failing and trying again. But that to me makes it so much fun, because when you make a discovery that no one has ever made before, or you prove something in a scientific manner, it's really satisfying. It's really satisfying, and I think I said this in my introductory comments that some of you are going to end up loving this class. At least I really hope so. So let's get started. I'd like to start my lectures. In fact, I do start all of my lectures with an outline of the lecture. I do that for two reasons. The first one is it helps you organize your thoughts. It helps you take things down in an organized manner that will help you on the study guide and the tests. And I hope that you are downloading the study guides first for the lecture and taking notes as you go along, because that'll make your life a whole lot easier. The second reason I do that has to do with learning theory. Now, we know that humans learn. All of our facts aren't just thrown into our head willy-nilly, randomly. They are organized. Our brain organizes them according to a whole lot of different things. But one of the things we do is we group like facts together. So I like to give you an advance warning of what's coming in this lecture. So when I talk about things, if you have this outline in mind, you can kind of slot them away. So when it's time to take the test, you'll have an organized structure to find them again. The other, that's the reason. Oh yeah, this is related to, I don't know if any of you have worked on study techniques or anything, but one of the first things they always tell you when reading a textbook is to scan the textbook first. Scan the whole chapter that you want to read first, because it does exactly this. If you get an idea of the structure and the organization of the chapter, you have a structure to hang your facts in. So I'm doing the same thing with the lecture. So use it. Okay, so the question of the day, what are research methods? And I bet that many of you don't really know yet, and that's okay, because it's a higher level type of thinking, and this is something that really, understanding research, the type of critical thinking involved in research methods, is something that really separates college graduates from non-college graduates. So you are getting into the good stuff here. Basically, what research methods are a set of tools to help you answer questions. And these tools are part of the scientific method, or science, which is a disciplined way of asking questions. So what you're really learning is how to use the scientific method to make sure that you can answer questions empirically, and we'll define that word later in lection, and follow a procedure that makes sure you answer the questions to the best way that we can. You're going to ask questions the right way. You're going to gather evidence that really is applicable to your questions. And you're going to show this evidence or present this evidence to others in a compelling way. So science is a disciplined way of asking questions, and research methods are a set of tools to help you answer these questions. Without understanding of these tools, you can be seriously led astray. And one example that I can easily think of is people who believe in conspiracy theories. And there are many reasons that people believe in them, and most of them are emotional, but when people believe these things, it can cause a lot of problems in society and in all different ways. because they're not using the scientific method to assess the claims made by conspiracy theories. Conspiracy theorists generally don't support or don't supply good quality information to support their points. They don't rely on the work of others. They act like they're the smartest person in the world and the first person to ever discover that, and that's not what scientists do. And they show very little proof. They don't show that they've tested their theories, that their theories stand up to the real world. So learning research methods can help you so many ways, and one of them is you're less likely to believe in conspiracy theories, which overall is a good thing. So I'm going to give you an example of how people didn't really base decisions on science. And fortunately, this is an example that didn't really do too much harm, just some wasted time and some wasted money. So some of you guys may have heard of the Mozart effect. And the basic idea was that listening to Mozart makes smart babies. Does this sound like a good idea to you? Well, it actually doesn't sound bad. And a few years ago, there was a widely publicized phenomenon called the Mozart effect. Headlines such as "classical music good for babies' brains" were common at the time. These headlines caught people's attention, especially the attention of new parents. Media reports indicated that parents were playing classical music to their infants in the hope of raising their children's intelligence. 1 million new mothers were given a free CD, which shows you how old the music was. Now they'd be given a free download code called Smart Symphonies, along with free infant formula. Clearly, the distributors and many new parents were persuaded that the Mozart effect was real. But was it? Lots of people thought so. Here's a picture of some of the products of these beliefs. Baby Needs Mozart, a collection of music, Mozart for babies. Baby Needs More Mozart. So lots of Mozart was going on with these babies. But the first thing you should do, if this is important to you, is to check out the research. And in fact, when investigators tracked down the research behind this, what they found, this whole phenomena kind of rolled out of control, was based on one study. And the study was in a quality journal. It was a journal called Nature, which was a very good peer-reviewed journal. But the details of the study were a little different than what researchers had generalized. So it wasn't based on research. Basically, what happened, there was an experiment in which a single group of college students listened to a 10-minute Mozart piece, sat in silence for 10 minutes, or listened to relaxation instructions for 10 minutes. So there was 3 different groups. They either listened to Mozart, sat in silence, or listened to relaxation instructions. And after that 10-minute session, everyone in the study, in all 3 groups, took a spatial reasoning test. Guess who performed better on the spatial reasoning test? The people who listened to Mozart, right? So there's might be something there. But it was definitely generalized too far. And furthermore, the researchers tested how long this effect lasted, and it lasted for about 10 minutes. If you gave the same 3 groups that same spatial reasoning test or a similar spatial reasoning test 10 to 15 minutes after the Mozart session, the Mozart relaxation or sat in silence conditions, 10 to 15 minutes afterwards, there was no difference between the groups. So the study doesn't really tell you that listening to Mozart doesn't make babies smarter, but it really doesn't address a lot of the things that this research was generalized to. First of all, The research was done in college students, and it was generalized to babies. Now, you don't have to be a genius in developmental science to know that babies are different than college students, right? So we've got an issue, and we're going to learn later, with the sample. The sample is the people that we're studying. Generally, when you try to apply a research finding to another group of individuals, you want to make sure that those individuals have something in common. And babies and college students don't have too much in common, besides the fact that they're human. But cognitively and how their minds work, pretty different. Second thing is the college students were given a test in spatial reasoning, and the advertisers said that Mozart made babies more intelligent. Is spatial reasoning intelligence? Well, you could argue that it's a part of intelligence, but intelligence, as we generally use it, includes many other things, such as mathematical intelligence, social intelligence, practical intelligence, verbal intelligence. So we've got that. The study didn't really address that. And then thirdly, the effect only lasted 10 to 15 minutes. So the implication was that Mozart's going to make babies smarter for their whole lives, and it only lasted 10 to 15 minutes in this study. So we can't say definitively that it doesn't make babies smarter, but that study is not enough evidence. And so what you're going to learn in this class is how to analyze evidence, how to make sure that the research you're using and the research you're generating, you will do a research project in this class, is the best that it can possibly be. So I will join you in a few minutes or whenever you want with the next part of this lecture.